Hello everyone. Today we are going to enter into the video series of operating system again, and I hope you all know about what we have seen in the previous video series. We have completed with the operating system introduction, its functions, and the major functions of the operating system as the memory management, process management, and the storage management has been completed out. And in the previous video we have dealt with the FCFS scheduling and the SJF scheduling. So followed by this types of scheduling, now we are going to look on into the two other most important scheduling policies called as the priority scheduling and the round robin scheduling. Come on, let's go into the video and search how this round robin scheduling and the priority scheduling is going to be processed inside the CPU. Coming to this priority scheduling, a priority number is assigned with each and every process. So this number ranges from smallest number to the largest number. So wherever the smallest number is given, that means that process has the highest priority, so that that particular process has to be executed immediately. So that has the utmost priority, though we have several number of processes waiting in the ready queue. And here in this priority scheduling we have two types, preemptive and non-preemptive. I hope you all very know about this preemptive and non-preemptiveness, which we have seen already in the SJF. And here I can say that SJF is a priority scheduling because the shortest job is processed first whenever there is a longest job is waiting inside the ready queue before the shortest job. So this is again a kind of the preemptive priority scheduling. And coming on to this drawback of priority scheduling, the main drawback of this is starvation. That means if a process is coming on with the highest priority again and again, that particular process will be serviced without servicing the other processes. So low priority process will be waiting for longer time, so that the higher priority process will be always executed by the CPU. And here we can give a solution in a such a way that if a particular process is again and again starts executing with the highest priority, then we are going to mark with an aging process. So this aging process is termed to be a number which is incremented whenever the same process is executed again and again. When it reaches a maximum value, then that particular process will not be allowed into the CPU for furthermore execution. So this solution is called as aging. Come on, now we'll go to the example and see how the priority scheduling is processed. So this is an example of priority scheduling given, where in the previous scheduling we will have only the process name with the burst time, and in some cases we'll have the arrival time. And here in priority scheduling, definitely there is a mandatory requirement for the priority number for each and every process. So here we have 5 processes termed from P1 to P5, and the burst time is given. Along with the each and every process, we have given the priority number. So P1 takes with the 3 priority, and P2 takes with the priority 1. Likewise it goes on. So when we take this example, it is clearly understood that P2 has the highest priority because it has the shortest number, very minimal number called as the 1, which has the highest priority to get executed. So P2 will be executed first. Next comes with the process number P5, which has the number as 2. So that will be executed after the process P2. So P2, P5, in this order the processes will be executed with the burst time. And as usual, the average waiting time and the average turnaround time will be calculated for the priority scheduling. And here comes another example where we are having the arrival time also. In this arrival time, based on the arrival time only, now the priority has to be checked. If process P1 enters at arrival time 0, there is no competitors. So obviously the process P1 has to be given the priority to be executed. So whenever the arrival time has been given, for each and every arrival time incremented, we have to see how many processes are there in the ready queue for the competition. So in that we have to choose the highest priority process, and that will be executed by the CPU. Thank you.